So let's think about it this way, right? What's another way I can represent the vectors? Because I know I want to look for u plus v, and if I'm thinking about speed and bearings and things like that, I know that the speed of this is going to be its magnitude, right? Because we're using the magnitude of the vectors to represent the speed. So I'll go back to this. If this is my vector over here, all right, I have these horizontal and vertical components. Right, so what's another way to write these? Well, I can think about this horizontal component as A, vertical component as B. This guy, this magnitude, we usually denote as R, right? So I want to think about another way to represent this vector. Why? Because I don't have the information that I want. What information do they give you here? Yeah, they give you an angle, which is, remember, that's not the direction of the vector, right? The direction of vector is from the positive angle, so I'll get into that in a moment. But they also give you the magnitude. So the goal is that we can express this vector, AB, in terms of its magnitude and direction, right? So r and theta. Does that make sense, what we were trying to do here? Right. So how do I think about this? Well, if you think about this guy, for example, if you took cos theta, what's cos theta equal to Harry in this situation? Well, over here, as in like, in terms of the letters here. What would cos theta? Because cos is adjacent over hypotenuse, right? So what is that?
No, I was just hoping you'd answer it for me. I was going to, and I'm like...
So here's the idea, right? Instead of A and B, I want to represent this in terms of its magnitude and direction, right? So what I can do is I can say, well, if I want A in terms of these things, I'll just multiply both sides by R, right? Okay? So A is the same as R cos theta. Are we okay with that? Right. I can do the same thing with B now, right? Angus, when I'm looking at this one, what ratio do I want to use for B in terms of R and theta? Yeah, right. So if I use sine theta here, I can say that that's the same as opposite over hypotenuse, or B over R. And so again, multiplying both sides by R, I've got this situation here, right? So the idea is, instead of this vector as A and B, I can write in this form. Now, they don't use this language in the Extension 1 syllabus, but this is actually called polar form. And reason why it's called that is because you have an angle and you have a length, right? So it's kind of like, if you think about a pole, like rotating around, that's the one. Yeah, so Extension 2 students might have seen this before. So here's our form here. The vector AB can be written as R cos theta and R sine theta. Instead of the coordinates as numbers exactly, like you can still evaluate these numbers, you can still swap between them, right? But you can write this form straight up now if you're just given the magnitude and direction. Does that make sense? This form is useful here because if I just have the magnitude and direction of a vector, I can still write them in this particular form. And that's exactly what's going on here, right? You think about this situation. I have one of my R values. I have 250. Do I have the direction of vector u? Yeah. What is it? 50 degrees. Right. How did you have 50? Right, so just be careful. This is why I say be careful between what information they give you. The bearing is 40 degrees, but the direction of the vector is 50 degrees, yeah? Does that make sense? Right. So I'm looking at this, I'm thinking, okay, well, I know that u, let's do it over this side now. So the vector u, okay, so the vector u, I can write it now as 250 cos, what was that, 50 degrees, Angus?
Yes.
Yeah. And then what's its kind of y component? The 250 sine 50 degrees, right? So just to clarify again, why is this one 50? Because if you're looking at the positive angle from the x-axis over here, which is also east, right? The direction of the vector is the 50 degrees measured in a positive direction. Yeah, is that clear? Right? Cool. And if you're wondering, hey, how do you go back to this AB form? Well, if you actually put this in your calculator, you'll get a number, right? So that's kind of that A value that's there. It's just that this is a nicer way of representing, first of all, because they actually give that information clearly, but also because if you put this in your calculator, it's not going to be a nice number. It's going to be like a lot of decimals, right? Okay, vector V. What's vector V going to be? Well, it's actually even easier, right? Because it's straight up, just like this. what's the direction of that vector? If it's just horizontal like that. 0 degrees, because it's mentioned that way, and it's also going to be a magnitude of 55 because that's its speed there, right? So vector v now, 55 close 0. So in this case, you can actually write it as, because if you know your exact values, right, this can just be written as 55 and then 0, which, like, that makes sense, yeah, because you actually also have the coordinate in a sense for this one. If it's just a horizontal line going across 55 units, right, and it's not going up anywhere, that would just be 55 across 0 up. Does that make sense? How, like, we can see that as well? It does what, sorry? You can use rectangular form as well. So let's actually try and answer the question now. What was the question? Find the actual speed and bearing of the plane. And what vector did I say that was again?
Sorry?
What vector did I say that the speed and bearing of this, the actual speed and bearing of this plane is represented by? Like, what are we trying to do here in this question? U plus v, right? This is the thing we're trying to find. All these things have been kind of leading up to it. Because if I can find u and I can find v, I can just add them together and then use my formulas to find magnitude and direction, yeah? All right, let's add these together. How are we going to add these together? Well, what I suggest is that for now, right, you can actually just write it as whatever you have here, right? I can just write this part because remember, we're adding x and y components together. I can add this 250 cos 50 degrees with this value. So the reason why I'm doing that is because I don't want to get any nasty decimals or whatever. This one, then I know that the y component will just be 250 sine 50 degrees, right? And this is your vector u plus v. And can you see why it's so important now to be able to find magnitude and direction? Because all you're going to do now is to find the magnitude and direction of this particular vector, right? So you want to try that for me? Tell me the calcs. What am I doing?
The one before the comma, square.
Yes, right. So that's why it's going to get a bit messy. That's why
Yeah, I see it.
250 cos 50 degrees
Looks creepy.
plus 55 all squared plus 55 squared. This is for the magnitude. And what did you say you got? Around 288 point something?
284.7.
284. Wait. What did you get, Matt?
188.44.
So what you said?
400.
Did you square root it? What?
No, I didn't even do it.
Okay. 280.4 what?
Did I do it right?
Yeah, that's fine. 4, what are the decimals?
Why is it plus 55?
That's enough.
Because remember, we're finding u plus v, right?
Yeah.
Yeah. Because 55 was the x component of v. So you have to add them together.
Yeah.
For u plus v.
So that's there,
Yeah.
but why is it on?
Then that should
You've
be
already
plus
got the
2.
55 on the
Oh, right. Sorry. Yeah, sorry. Yeah, okay.
It should be 250 sine.
Yes, you're right. Sorry. 250 plus 250
How many decos?
sine 50 degrees.
2 decos.
But that's what I've got in the game.
2 decos?
What did you get? 284.
Wait, did I square the first one? I think
No.
I did. No, I did. It's just if you go across further, because there's the plus
Isn't
50
it plus
there.
50? Yeah.
Tell me
Yeah,
it's
288.4.
You like that?
4-4?
Yeah, no, he did some lot of bad
446,
stuff.
so it will be 45.
Yeah, so let's do 2 decos. All right, last one. Direction, right? If it's in the first quadrant,
Yes!
if it's in the first quadrant, yeah, what can you do, man? Well, think about the direction. That's this guy. That's this angle here, right? If it's in the first quadrant, right, think about what was the definition of direction. Yeah, Harry? Okay, well, help me out with this one. Man. I have a I have a vertical component, I have a horizontal component, yeah? So, if I want to find the angle here, what ratio am I looking at? When I think about your directions, we have a definition for that, right? I want this side and this side in my right angle triangle.
Harry, it's tan theta.
Sir, did you know that it is tan theta?
It is tan theta, well done. So we take our horizontal and vertical components, which we can see over here, horizontal and vertical, yeah. So I can
It
just,
wasn't exactly the hyperbole. budget for.
What was the budget?
3 million.
That's it.
Yeah.
I don't know what that is in context and stuff, but. Alright, so opposite over adjacent. So what component over what? Just make sure you're getting it right, Harry, right? So we've got our horizontal and verticals. So opposite over adjacent, it's your vertical divided by your horizontal, yeah? So this guy divided by this guy. And because we're in the first quadrant, we don't really have to do any changes. That's why it's good to draw the diagram so you know what you're doing, right? And just because you don't put like 50 plus 55 in the brackets there, it's 50 degrees. So you probably should have done that up here as well. And what angle is that for theta?
Yeah, but you'll have to check my answer.
Yeah, no, I trust in you.
I got 41.6.
All right. And Matt, what did you get?
Let me put in the calculator.
Thanks, Harry.
6 what?
You got to hear about
41.6.
Recurring? Or just
41 degrees, 36 minutes.
41.6. What are the other decimals? What were the other decimals?
41 degrees, 36 minutes. Yeah.
0.60095.
And then we say we'll round it to the nearest minute. 41 degrees, 36. Yep. Yeah, awesome. Well done, guys. So that's motion using vectors. Hopefully next lesson we'll look at some more applied examples and then we'll also touch on projectile motion as well. Okay.